This module introduced you to the concept of a delegate. This is a type-safe function pointer in C#. It allows you to reference a method that can later be invoked. We introduced the delegate keyword. This lets you define a required method signature. You use the delegate keyword followed by the method's return type, the delegate name, and finally, the required parameters. You can then use this defined delegate throughout the entire application by using the name. This has a very small memory footprint and allows for great flexibility and extensibility. You can indicate that you want to use the delegate, which will then let you pass a reference to a method that matches the delegate's signature. You saw how to pass a reference to an existing method and also how to construct an anonymous function using a lambda. The lambda can be defined in two different ways. One uses an expression, which is ultimately a one-liner, and the other is a statement that lets you use multiple lines. And you can use the return keyword if the delegate requires you to return a value. It's good to remember to keep it simple. If the lambda statement gets too complex, it might be worth to extract that to a separate method to increase readability. A huge benefit of the lambdas are that they make the code easier to read, because the logic may be defined in the same place as the method call, as well as the fact that it can easily capture variables and use them inside the expression or the lambda statement. The compiler will take care of the internals for you, and as efficiently as possible, reduce the memory footprint and complexity. On the receiving end of the delegate, you can invoke this like a normal method. The problem is that since this is a reference type, the reference might be null, and you could get a null reference exception. It's wise to use the null conditional operator together with the invoke method. This will only invoke the delegate if there is one defined. Don't confuse invoke with begin invoke and end invoke, as those are no longer recommended to be used. They were used in the past to run the delegates asynchronously. To execute the delegate asynchronously, you'd use the task parallel library instead, which you could learn all about in my course on asynchronous programming. The delegate that is invoked could be a multicast delegate, which means it is a chain of methods that will be executed sequentially. Anyone with access to the delegate could modify the invocation list, either adding or removing existing methods from this list. Another important note of publicly accessible delegates is that anyone can invoke them. Finally, you learned that you can use action or func to define a delegate without having to explicitly define the delegate with a method signature. They both support a lot of input parameters, and the func allows for a generic return type. I can guarantee that you will be using delegates and lambdas quite heavily throughout your applications. If we want to extend the warehouse application with the capability of signaling when certain stages are reached, how would we approach this? Would you suggest that we publicly expose an action for each of the different signals? In reality, what we'd like is for a way to subscribe to an event. Another way of looking at that is if an order placement takes a little bit of time. Is there a way to get notified when that is done? Could we somehow get an event raised to get the status of the order? Let's explore this in the next module. I really hope that you are as excited as I am to proceed in this course.